saying bienvenida a Nueva York y bienvenida a TriSwift, Berta.
So my name is Berta. I'm going to be talking about ARKit on face tracking. As she said, I'm an iOS developer for Nebora. It's an European company. And now, basically, we have around sometimes investigation time where we're now working for a client and we get to go do like deep dives into a subject or learn something new. And that's how I started looking at ARKit. So I started because I've seen it on Twitter videos, probably we've all seen it, and at WWDC and Pokemon Go, but it looks kind of like a gimmick, and full disclosure, that's what I thought too. It looked like, okay, this is more of a marketing plot than anything. It makes really cool videos for the marketing people, and it gets like 1,000 likes on Twitter, but I cannot imagine any time that I will use that on an app. So it was really funny because this ARKit started similar like when CoreML came up big on WWDC, and machine learning got immediately acknowledged by every iOS developer. This is amazing, we're going to use it, how do I learn how to put this in my app? And ARKit was kind of like on the sides, right? So one of my intentions with this talk is to like make you realize the powerful technology behind it, how amazing the API is really and what it does, and that it has way more other things than just actually making cool videos for Twitter. So this is a little bit of the agenda. I'm going to walk a little bit about what AR is, just in case anyone is not familiar with, even though the talk focuses on face tracking. And then I'm going to talk a little bit about the ARKit face tracking and, well, the future, some of the use cases that I see going on that could be applied to a lot of apps right now. So AR what? ARKit does a shit ton of things, and basically we're gonna, as I said, we're gonna be focusing on face tracking, but it's good to know that it does a lot of other things. So it does face tracking, but it also does world and scene understanding tracking. It does image tracking, since ARKit 2, and 3D object tracking. So it understands and can maps out almost any reality that you can think of. Then it also helps you do the rendering. So it has already built-in methods for you to render 3D models, which work really well. They work over a scene kit. So if you've ever worked with a scene kit, half of your job is kind of done for you. And it has persistent and multi-user since like ARKit 2 also. So that like one API handles a lot of things, and it is really powerful. And if you have some time, you should check it out. So these are some of the words that I'm going to be using through the talk, so I'm going to explain a little bit. I'm going to start with like the big thing. So the big thing, what you're seeing on the screen, that's a view. That's called an AR scene view. This is basically the boss of everything. This handles everything. So you put this as any UI view. You can use auto layout. You can do it in storyboard. You can do it with frames, and it will handle everything. It will automatically ask the user to allow the camera. It will start a camera, and that will be the main focus for you. The AR scene view also handles the AR session, which is when you start the tracking, whichever tracking that you want to do, world, in our case, face, object, or image. That's run on the view. And it also handles the view delegates. The delegates actually render the 3D models. So this entire AR scene view, all those, I don't know if you can actually see it, yeah. All those like little dots, they're called like feature points. It's how world tracking works a little bit, how it understands the surrounding. They're also translated into AR anchors. That's like a very big definition for a specific object on a 3D model, and there are different type of anchors. We are going to be using an AR face anchor, which is class inherited from AR anchors. So those are some of the words I'm going to be throwing around so you can know a little bit more about it. If you have never done a Getting Started to ARKit blog post, looked at it, or ever seen a talk, I highly recommend you check out the talk Glenna Buford did last year here at TriSwift. It's online, because she went more a little bit deep down on this, and it will probably help you understand a little bit of the context if you're missing it. So this, just in case you don't have time to see this talk, press too much. This is what the code looks like. So the first one is how the renderer functions look like, and the second one is how you start a session. So you have a view, you have your delegate set up with your render functions to render whatever you want on the scene, any 3D model based on a scene kit, and you have a configuration running that tracks, in this case, a face. That's all you need to get AR set up. So with this, you have an AR app set up, and now we can deep down on face tracking and how it works and what information ARKit actually gives you. So ARKit gives you 3 types, more, but the 3 basic building blocks of face tracking are face anchors, face geometry, and a scene face geometry. I'm going to be talking a little bit more about this and then showing you some demos on how they work. So face anchors, as I said, they come from AR anchors, and they give you the position and orientation of the face. So an AR face anchor is literally just the face. You can see it in the video as this mask. That's how it's representing my face. I rendered that so you could see it. And it's relative to the wall. So as you move, it will get updated. The AR face anchor has a geometry inside of it, which is the AR scene geometry, and it has the blend shape movements. I don't know if you remember from WWDC 2018, the keynote, that they announced that they could do Memojis with the tongue out. That's one of those blend shape movements. There's 52 of them, and they track the movements that you do. So when you blink, when you move the mouse up and down, depending, there's different movements for moving one lip up and the other side of the lid. It's quite complex, and it gives you a lot of range of possibilities. And the face geometry is the 3D representation of the face. So before you saw a mask, now I think you can still see it. Yeah, you see the mesh. It gets created by a metal device. So this is when it starts answering the question of why the iPhone 10 only has a face tracking and not the other iPhones. It uses a 3D camera and to mesh this topology, this face mesh. That's the anchor. That's the geometry of the anchor. So when you start tracking, this is what it reads about, in this case, my face. This never gets updated unless you reset the tracking and you create a new one and set up another face. AR assumes, and rightly so, that suddenly my nose is not going to grow bigger. It's not going to change. So the mesh itself doesn't get reset, doesn't get updated. What it updates is all these little vertices that you see here, the position of where they are. These things are called vertices, and there are 1,220 of them. All of those are like little points on a face. And every mesh that you do, every face that AR tracks has all of those vertices, has all of these triangles. For example, to know the position at any time during the tracking where the nose is, you would look for the vertices number 9. That's the nose. So you could basically anchor something on the nose just by asking on this geometry, where is your vertex position number 9? And ARKit handles all of this. It handles the updating, and with the render methods, you just update the geometry constantly as it updates if you have something rendered onto it. I will show some of the code also. So as I said, the mask geometry gets created at the beginning because it only gets created once. Every time you reset the tracking, if you change faces, yes. But it's AR scene face geometry, and you use the metal device for it that you get straight up from the scene view. Again, everything comes out of the scene view. And you can just create a node using that geometry. So straight up, that face that I showed you before, with the scene view set up and the session configuration set up, if you add this to the scene view, that face mesh the created with these 3 lines of code, you have the mesh that you were seeing on the video. That's so easy, and it's already calculated for you, and you can already see how it tracks when the user moves and in different lights and everything. If you wanted to do a little bit more, you could also create your own node that calls face mesh that it inits with the geometry also. And then here, for example, I set the fill mode to lines, which is what shows the lines. If I put it to fill, it's the mask that we saw at the beginning, and then I change the color. So that already creates a really creepy mask effect, and I barely had to do any code or create any 3D models. It's pretty nice. And I also I did here an update method basically to help me update the face geometry. So every time the face anchor gets updated, which this gets triggered by the render method on the delegate, I basically update the geometry of the anchor. So every time I open my mouth or turn to the right and to the left, I change the frame, and ARKit knows that it will probably need to update and re-render this. So it hits the render methods on the delegate, and I set code there to update with the new geometry, which doesn't, again, it doesn't create a new geometry, it just updates the position of that one. the position of the vertices. So it would take the position of the mouth, of the nose, or of the eyebrows, or like anything that's on my face, basically. So, okay, so show me. I'm gonna try to see if I can show you how these vertices look in like real life. We'll pray that live demos work, because it's always stretch. But so, yeah. So this is the. I'm gonna take my glasses off because sometimes it works differently. But this is the mesh. I think you can see it. I cannot see it yet. But as you can see, I can open my mouth. The mesh is only the vertices, so the blend shape movements and the vertices are different. For example, tongue out doesn't work in the mesh. It doesn't track it. Suddenly I'm over the mesh, right? But it does follow the nose, and it does follow the eyes, and when I open the mouth. So those are all these like little vertices are where I could place things. If I wanted to place a pair of glasses, for example, fake ones, I would look for the nose and I would look for the vertices of the eyes, and I would be able to actually place them correctly and show them to the user how they will look to them. And ARKit does all of that for you. You just need to know which vertex is the nose and the eyes. And then on this one, I actually get the blend shape movements. So let's see. Well, yeah, I already blinked. So I made it that when you blink, it's supposed to like show, but it's a bit tricky because the blend shape movements is a double, and it goes from 0 to 1. And yeah, that definitely doesn't work with glasses. It has problems realizing that. And sometimes it always hits the left eye because apparently I don't blink very well, I realized. I blink, even with, my left eye is fine. When I blink with my right eye, I also close my left one. So it kind of knows this. The blend shapes go from like 0 to 1. So 0 would be like, I have my eyes completely open, and 1 would be, I have my eyes completely closed. And you can basically just like play around with that and see how it reacts. The mouth one was really tricky because there are so many different types of mouth blend that there were some of the shapes that I, honest to God, they were in English, and I wouldn't know how to actually move my mouth to do that. And I tried, but it was just, I wasn't triggering them. So I thought eye blink right, eye blink left was much straightforward for the demo. But they are like, again, like 52 of those. So you can get them every time the frame updates, you basically check on the geometry if these blend shape movements in the anchor have actually changed. You can check that float value. If it's 0 or if it's, in my case, I put it to like minus 0.5, I do nothing. But if it's bigger than 0.5, means I have probably blinked. And then I show the label. But you can do a lot of other things with that. Now, this is the last step. AR scene face geometry. So the AR scene face geometry is a part built upon a scene kit that actually renders things onto the face. So so far, everything that I've taught before, face anchor and AR face geometry, it actually is like the backbones. It gives you data, but it actually doesn't show you anything. The AR face geometry is the one that gets all the rendered data and actually shows it on the screen. So it's really important, and it is based on the scene kit. So if you never open a book in the scene kit because you don't do video games and you never thought you had to, you might want to rethink this and open it. And it gets updated from face geometry. So they are very tied up together. When you update a face geometry, you can use that new updated face geometry to automatically update their scene face geometry, which is really nice. So once you have the model rendered, it kind of follows you around. It also does, it allows it to do something that is one of my favorite things, and it shows a little bit on this code, which is called Occlusion Geometry. So you know how if you've ever like look around or play around with an AR app, there's this, it looks cool, but the moment that you try to place something behind or you move around and there's a chair in front, the object is never behind. There's no way to actually put something behind what it's supposed to be. It understands that that's a chair, but it doesn't have, it cannot hide the 3D model inside, like under a chair, right? And with the true depth camera on the iPhone 10 and face tracking, you can actually do that. The mesh that I showed you before is a face anchor and is a geometry of your face. So you can actually use that as in a transparent way, as in it doesn't show back to the user. So the first line that I do here after init geometry is basically setting the material of that geometry to basically transparent, nothing. And you can add that to the node. So suddenly your face becomes part of the scene. I mean, it was always part of the scene, but it becomes part of the 3D scene. And it's transparent, meaning that when I add the second node, which in this case was like the NYC letters, which I'll show you later, that node, those two nodes can actually work together, meaning you can have physics effects. You can see if they are too close. You can adapt to that. You can actually show something behind the user because it understands that that's their face and that like a hat should be partly here, but it should not show this part here because that's a face of the user. Or the glasses should not like look really weird over the screen. And it's really cool that you can actually do that. You can actually make the face of the user you are tracking being part of the scene and react to physics. So there was a couple of examples of games that were doing that, where they were using the avatar of the user and making it like being part of the scene they were working on. And it's really cool to see like if there is a, like I think they would show you like a bomb, and it was just like explode, and it will react, it like exactly explode where you track here. There was a whole physics things involved, and it looked quite real. So that's one of the things that I love the most. And that's the second demo that I have, is to show that. And I think I need to take my glasses off. But as you can see here, my nose is cutting a little bit of the end because it understands that my face, that's the same code. This is the code you were looking at before, most of the entirety of the code. And it is placed in the vertices of my mouse, my nose, sorry. And it cuts some of it here because it's not perfect, but it understands that this is my face. And it's part of this, and this should fit in it. It shouldn't be overlay. It shouldn't look this fake. So that's actually really good. So the title of the talk is called Memojis Under the Hood. So the reason why it's called this is because that's how Memojis were built. I assume I don't work for Apple, by the way. If I'm wrong, let me know. But this is one of the things that Apple gives you. And if you can see, it uses the blend shapes that we were using before. This one, which is also not perfect. I cannot blink. You are realizing this, right? I think the glasses don't help, but yeah, better now. Yeah, but I still cannot blink properly. Okay, let's move on. But that's how it works. Each one of those Memojis that you saw so much, or if you have an iPhone, if you have an iPhone 10, you actually can play around. It works using those three things I said. The scene face geometry renders the Memojis, which, unless you have an entire Apple team to create that beautiful fox or robot, you might have maybe more problems creating the 3D models. But the other parts are blend shapes and the vertices. Know where your things are, know how to put the face, use the vertices to put the models correctly, and then use the blend shapes to make it look when the user opens a mouth or takes a tongue out or blinks to follow that. It is very similar to the code that I was showing, and it was quite simple. Most of it is done by ARKit, and it gives you a lot of information you can use. So the future. So obviously, the first thing that comes to mind when you see this type of things are face alterations, like the robot. Oh, I went too far. Like the robot, but we've also seen one of the possibilities with face identification, especially based on security with the Face ID on iPhone 10. But that could be used for like your bank account. That could be used to like checking into events. And you don't even have to render anything on the screen. You can just use face tracking to get that geometry model and be able to store it or compare it and keep it for security or identification purposes. You can also use it for occlusion geometry. So that's more rendering things, but it could also allow for very interactive experiences. You could change the background of a picture of a user. You could change how they look, where they are. You could do it, since this works with wireframes, you could actually do it live. You could change the background live while the face remains the same. And one of my favorite things of face tracking, of possibilities that it has, is accessibility. Because one of the reasons I put one of the first examples on blend shapes doing labels is that you can use this completely on the background. Doesn't mean that you have to always render something on the face of the user. The user doesn't really necessarily need to know that this is happening. Well, it is to know for legal reasons. Don't spy on users. But it doesn't necessarily need to see that. It could be used for accessibility. There's people with Parkinson's disease that swiping is really bad. Even if it's accessibility not in the way that someone is disabled or cannot swipe, it's a different way for your users to interact with your app. You can do a nod to like scroll up instead of having to do like this. You could turn around, you could blink, you could do anything that you want with this and just have it react the same way that you react to a touch of a button. It opens up an entire new possibilities of how you get users to interact with your app. And I think that's really powerful, and I think that's really important. And I think we should be thinking about these things and actually applying and seeing how we can get our users to interact with the app or open a new reality of our app in their wall, even if their wall is just a small bedroom at that moment, even if their wall is like the middle of Times Square. We always try to make the best apps, but at the end of the day, if our app is only used by 5 people 1 minute a day, it's probably not going to be very successful, no matter how well it's been built. I think ARKit opens up a whole new possibilities of how we get people to interact and stay with our apps, and I think that's worth considering. And thanks, that's my talk.